recording. Awesome. So today we're on with Tim, and Tim is in Georgia. And just to reiterate, the point of this channel is to highlight the skill sets of developers that really know what they're doing. There are a lot of developers out there. There are more and more coming into the market every single day. There are a lot of freelance developers out there, contract developers out there, and it's becoming more and more difficult for the good ones to highlight themselves as sort of the signal in the freelance noise. So what we're doing is meeting with programmers, having conversations with programmers in an effort to highlight the skill sets of competent developers, not only on their technical front, but on the personal and soft skill side of the equation as well. So we do that through sort of three areas in this conversation. The first 10 minutes or so is a little bit of background, how you got into programming, what you like about programming, what you don't like about programming, some of the stuff you've worked on. From there, we get into a little more tech talk, a little more technically oriented, and then the final part is we're actually going to walk through some code that you have sent over and dive into some of the technical decisions that were made, some of the language decisions that were made, etc. So, Tim, why don't you start out, kind of introduce yourself, and why don't you start by telling us how you sort of got into programming?
Yeah, sure. So I'm going to date myself a little bit, but I had an original Xbox. And so not Xbox One, the Xbox One. So I started off by having a problem with a game. It was called Halo. Actually Halo 2 to be exact. The issue was that one of the Easter eggs, if you will, was very difficult to get. So I set out to see if I could somehow make my life a little bit easier, and that got me down a road of some craziness. So I ended up soldering some hardware onto my Xbox, going out and buying Splinter Cell and then hacking a save game for that. And then with that save game, I was able to sideload a different OS onto the Xbox, which was, I forget what it was at the time, but it allowed you to basically to transfer the entire Halo game over onto your computer so you can edit it and then send it back over to the Xbox. So, yeah, that's how I got into programming.
What was the Easter egg? It must have been highly coveted.
The Easter egg was you could only use it on that single level, and it was a OP gun.
Uh-huh.
But that was basically the only reason why I wanted it. But from there, I was able to actually extract the game's assets. There was a whole community around it with open source software and things like that, which really opened my eyes to what I could do. So nothing was stopping me at that point.
Right. So where did you sort of go from there?
From there, I actually landed on a Carnegie Mellon page. They were a contributor to Disney's open source 3D game engine called Panda 3D. And Panda 3D runs on Python. And this was before we had the turnkey solutions like Unity and Unreal.
Right.
So I wanted to make games, or at least I thought I did. So I decided I should learn Python. And then I was like, all right, well, Python has more interesting things than just games. So I started making little toy programs for myself that automated some tasks. So.
Nice. And so what would you say your first big project was outside of hacking Xbox?
Let's see. Well, my first big project. Ooh, that's a tough one. Well, I would say so. I got my first real internship doing programming at Unilever, and one of my tasks was to basically be a project manager and make sure that the developers overseas were completing tasks on time.
Right.
And we used HP Quality Center at the time. And at the end of every day before our big meeting that took 2 hours to do, we would have to pull in a list of all the HP Quality Center issues and then see if anything was overdue or if things weren't getting done on time. So my job was to compile all that data into an Excel sheet and like present it every day in the meeting. And that to me just I died every day a little bit on the inside having to do that. So what I did was I automated the entire process. I found that HP Quality Center had an API. I had to learn Visual Basic. Disgusting, yes.
Yeah.
And so I wrote a plugin for them that literally took our 2-hour meeting into a 30-minute meeting. People could press a button, log in with their Quality Center credentials, and then download their spreadsheet for their particular thing and see what tasks were overdue for them. So they actually used that throughout the company, and I was commended for it and then actually invited back to make it a program. But I had to decline it because I got other offers that were better. But yeah, that was my first major project. So.
Project? That sounds like an interesting project. Where did you go from there? You said you got other offers that were better. Where did those take you?
Well, I got a co-op opportunity at BMW.
Uh-huh.
So I worked at the Spartanburg, not the plant. I actually worked at the Innovation Center. Basically, our job was to enhance the driving experience. And from there, I was given money, resources, and pretty much a playground to do whatever I wanted.
Uh-huh.
So I successfully launched a pilot program that was featured at BMW Welt, which is the BMW World in Munich. I launched a pilot in New York and a local pilot in Greenville. That pilot actually went on to beat the turnkey solution that they were currently using and was far cheaper. Nice. And it could run on anything, including an iPad, which at the time it required the HP Z600s, which was the Ferrari of workstations. The base model that could render the 3D software was about $13,000. But the solution I offered was about $500.
Nice. So, and that was all at BMW. Where did you go from there? How did you get into mobile dev? Is there
at BMW.
At BMW.
Yep.
Was that some of the iPad stuff?
Yeah, so I made an iPad application for dealerships where a user that didn't necessarily want to. So the problem is on Sundays, people come there to window shop, right? Because there's no one there. We wanted to give the user a better experience, especially for customers that come.
When you say there's no one there are no employees there? There's the shops.
Yeah. So the shop is closed.
So people like to go in and just look through the windows at the cars?
Yeah, they like to look at the cars and see like what are the options, the color options and stuff, and they just kind of meander the parking lot, and all those missed sale opportunity.
Right.
Completely missed. Mm-hmm. So what we did was we said, all right, let's make a digital key drop off whereby you could, with your phone, you could walk up to a kiosk that was behind a glass, and we use the Xbox Connect to get like the UI gestures and stuff where you can interact with it. And it would basically.
You had already hacked Xbox?
Yeah, that's one of the reasons why I really like that project. This was Xbox 360 and the Connect.
Throwback to the old days? Yeah,
throwback. Well, funny story, but yeah. But basically, this project turned into, it actually worked. We demoed it. It allowed the user to download a QR code and temporarily rent the car for 30 minutes. And so the key would be dispensed from a door, and it would register you as the person who took it. It would take a picture of you and then send that data up to the basically the sales department, and they would give you a call back on Monday and to either say, hey, you have the car still, we need it back, or how did you enjoy the car?
Yeah, I can see that being problematic, having to go collect cars from everywhere.
Yeah, I mean, the pilot program was actually pretty successful. We did see an uptick in sales. People seemed to be more comfortable with that experience. Although at scale, there was some concerns about safety and things like that.
Right. I mean, I think my first inclination I mean, that's just an opportunity to drive a really nice BMW around really fast all over the highway. Yeah.
There was some technical
with no supervision.
Yeah, we actually didn't launch it on a Sunday and let people do it. It was a very controlled environment, but we got very positive feedback from it, and the customers seemed to really enjoy the experience of not having to deal with a salesperson.
Right. Maybe they need to work on their salespeople.
They said automate it, so I automated it.
Yeah. So that was your delve into mobile, like you said. So where did you go mobily from there?
I just fell in love. Open source projects. Basically, pretty much all my other jobs were very focused on iOS and mobile development. I went on to actually create an application that we have a patent for. Although that company is defunct now, I learned a lot about just how to write apps in general for users and what it means to have a good user experience and what it means to have a bad user experience. When we first launched that product, we actually took out an entire server cluster from, at the time they weren't owned by Google, but it was Firebase. Back when Firebase wasn't owned by Google, we actually took down their entire East Coast server cluster.
How did you manage to do that? I've done that for my own company's tech stacks on AWS, but I don't think I've ever actually managed to take down AWS.
Well, so they provided a little program called Flashlight. And basically what Flashlight would do was hook into all the real-time aspects of the Firebase and throw it into an elastic DB. And at the time, we needed some pretty crazy search algorithms, and Firebase couldn't query fast enough. Right. So we used Elasticsearch to do that. But the problem is that was hitting it so fast that it actually just crippled their server, and we found a flaw in their system, and they just kicked us off. So they said, fix it or get off, and they kicked us off. So
kicked you off?
Yeah.
So what was that company? Can you talk about that a little bit?
Yeah. So the company was Geekin Ventures and Geekin Radio. The premise behind that was if two people are worlds apart or right next to each other, it would allow them to synchronize the playback of their music across any network, and they wouldn't have to be connected directly, but they could listen to music together or play back any kind of multimedia. So think about at a concert. I don't know if you've ever been to a concert where they give you headphones like silent DJs. So imagine if you have a DJ, but there's no loud music, everyone wearing their own headphones, and they have a very immersive experience. So that's kind of what we were capturing at the time. And this was, we had the product during the golden age of SoundCloud, before SoundCloud got crippled, basically. Yeah. So, but we did successfully launch the algorithm that I helped develop and have a patent for, which was the actual simultaneous playback. We got within plus or minus 50 milliseconds, which to the regular untrained person, non-musician, you can't tell the difference between two devices playing back. So it's a stereo effect.
Right. So how did you develop that algorithm? Can you tell me a little bit about that, or is it too?
No, it's a public patent. Basically, you have. So we used a lot of pre-existing technologies such as a network time protocol, but we used the simplified version of that, SNTP. And so we applied that kind of technique to cell phones. I actually learned a lot about time. Cell phones can have up to a maximum of 5 minutes discrepancy in its actual time clock. So you could have the incorrect time on your phone, but because the cell phone tower is actually telling your phone that it's this time, but it's actually not. So we found that.
That's concerning.
Yeah, I mean, it is, but the use case is your phone doesn't exactly need the perfect time. So what we did was we used the NTP protocol to synchronize with an atomic clock. Those two were tick and tock, which are maintained by the US Navy, right? So our server would get the definitive time. And so it would tell other devices, this is the time that you need to sync to. And we would analyze the device and do like an upper and lower bounds, and it would squeeze tighter and tighter and tighter into perfection. And all this would happen within 5 seconds of a playback. So within 5 seconds, you would be perfectly aligned no matter what the user did with their playback.
So where did that algorithm live? How did you, what language did you develop that algorithm in, and what were some of the more interesting aspects of working in that?
Well, at the time we were using Swift 1.0, which was not as a mature language.
Did you write the algorithm in Swift?
Partly. Part of it was in Swift, part of it was in Objective-C. The Objective-C part was the SNTP protocol. At the time, there was already one available in C. And as you know, Objective-C bridges well to C.
Right.
And so we wrote the audio part in that as well. So the audio player was written in Swift, and we use the AV Audio Foundation for that because it allows granularity control over where you get placed in a track. So it was a combination of Objective-C.
So Swift 1.0, that wasn't very fast, was it?
It wasn't very good at all.
No.
Also during the time, we went from Swift 1.0 to 1.2 to 1.4 and then 2, all within the short time span of that company's life cycle. So we were not only catching up, we were also having breaking changes at every corner. And then they introduced 64-bit requirements. So if you remember the iPhone 5C, actually a 32-bit iPhone. And so we had 32-bit users, and then we had 64-bit users. So we had to deal with the fact that if I ask it for a number or an integer larger than the 32-bit space, it'll crash the phone. So, and at the time, Apple didn't handle that in the Swift language.
So let's dive into, we've kind of moved in a bit of a technical direction here.
Sure.
Your primary areas of focus would be mobile, specifically iOS, correct?
Yep.
And you do a lot of work in both React Native and native programming. Can you talk about maybe some of the trade-offs between the two, your experiences between React Native and native programming? I know you have some opinions on that.
Yeah, I mean, so I want to dispel, I don't have it's a negative opinion only because of some of the technical limitations that are involved with React Native, specifically the JavaScript bridge to native. They use sort of like a serial queue where it fires off events that are piped back into the primary OS. One of the other issues with that is that Android and iOS have different JavaScript engines. So execution behavior at the actual like native level is vastly different. And that presents a problem. Specifically on Android, we saw a ton of problems that were just out of our control. And in order to actually upgrade the system to solve it, we would have to basically go into C and rewrite some of the Facebook stuff. So did we want to do that? No. We also jumped in the technology really, really early. So it hasn't really changed much, but it's getting better. It has a place for prototypes and for quickly doing an MVP. However, at a production level, I don't think it will give your users the experience that someone would be looking for. Yes, it's cheaper because you have a single code base, but you make trade-offs. And if
Right.
a company were to accept those trade-offs, that's totally fine. They just have to be aware of that.
So now any new project you would start would be, you would want to do it entirely in native and Swift, right?
I would prefer native and Swift, mostly because Google and Apple have come up with two languages that are extremely similar, which is Kotlin and Swift.
Oh, Kotlin's a Google language?
Well, no, it's not a Google language, but Google has finally accepted it. It's actually by JetBrains.
Yeah, okay, that's what I thought. Yeah.
Sorry, when I say Google and Apple have come up with, Google does contribute heavily to the open source Kotlin language.
Okay.
You can see some of their contributors, but the original brainchild behind it was JetBrains.
Okay, yeah, that's what I thought. But whereas Apple actually was the
creator of Swift. Yep. And so they're very similar, and you can basically maintain the same code base, sort of. And they're also doing a lot of work with bridging some business layer code into Android. So
let's talk about Swift a little bit. You got in working at Swift 1.0, which is, I think, a lot braver than most people. How have you seen the language evolve over since it launched almost 5 years ago now?
Well, we have magical things called extensions now, which are great.
Yes.
The evolution of how they handle generics is wonderful. Specifically with it allows me as a developer more fine-grained control over sorting, scanning in a string array or string for specific stuff, and just the overall stability of the language and syntax sugar, essentially.
Compile times go down.
Yeah, compile times vastly go down, and they started adding more and more native runtime features that aren't bridging back to Objective-C. So you're not taking that penalty hit going back and forth between the two bridges. So performance has been exponentially increasing, and I believe they're introducing a runtime framework, which is similar to, I would equate it to Microsoft's .NET framework, whereby there's a core set of APIs that you interact with, but you could do it in C#, F#, C++, Visual Basic, that sort of thing. I forget, there's actually a technical term for it. I just don't remember it at this time.
I'm not sure what it is, but so obviously iOS is all in Xcode. Are you a storyboard guy or non-storyboard, or what are your thoughts?
So all my recent projects have no zibs or storyboards at all.
And why do you like to go that route?
I like to go that route because although storyboards provide you a good visual of how something is going to look, you make a sacrifice in that you have no control over how that file is actually generated. And so if you have a merge conflict, so say you and a friend both open storyboard at the same time, and you try to merge it, let's say one of you adds a view controller and the other one adds a view controller, you now have a conflict.
Right.
And you just cannot.
Merging zip files, it's a nightmare.
Yeah, you make a choice. Who did the most work on that storyboard, and that's whose work you go with.
From a project standpoint, from a structure standpoint, or a design pattern standpoint, why do you like non-storyboards versus storyboards, or why do you like doing code in manual layout?
Well, so although the performance gain is minimal, you do get a performance gain. Your bundle size is smaller because there's less code, and you can easily track the changes via Git. I mean, everything you do is human readable because a human wrote the code, so you can track the changes quite easily. And now that Swift is more mature and auto layout like language is also more mature, the need for storyboards is becoming less and less.
Uh-huh.
So
Apple's pushing them pretty hard.
I know Apple pushes them really hard. Again, for a person that's new to iOS, coming into a project that has no storyboards or zibs is very intimidating.
Right.
I will say you have to really understand how iOS and the view lifecycle happens if you're going to do that. But personally, I group things by function.
Right.
So, for example, if I'm writing a user story of I want to be able to log in, well, I group all the login components together,
Right.
so that if I need to rip it out of a project, I can. It's drag and drop.
Right. And the rest of the project doesn't break. Whereas if you do something like that with storyboards, I mean, it's a giant tangled mess of segues going all these different ways, and you have to visually remap that, and then
there's no type safety for segues, and there's no type safety for storyboard IDs.
Right. Oh yeah, absolutely. You got to match all the storyboard IDs, and then there are a bunch of external dependencies that are not explicitly spelled out right there, which you can do all in code. So do you do auto layout in code, or are you do manual?
So I would not ever encourage manual layouts unless you absolutely have to, and there better be a good reason. But yes, I do auto layout by hand in code, and
so that's using the Apple's actual API within UIKit, or is that using some sort of third party like a SnapKit or something like that?
No, I use the anchors, the new anchor API. I hated the visual layout language, which was not typed at all.
No, that was all strings, if I recall.
Yep. It was all strings, and it made no sense whatsoever.
It was very confusing.
Right. No, the anchoring system is it brings two advantages. You can do safe area layout, which is iPhone 10 aware with a little notch. So if they decide that they want to add 4 more notches to the screen, it won't matter because you have a safe area layout. So although that would be a terrible design choice, who knows?
Who knows what Apple's doing?
Who knows?
They do their own thing. Cool. So let's some of the code you sent me here. I'm gonna go ahead and share my screen. Let me pull up Xcode. Where did my Xcode go? Let me see. There it is. Change my background color. All right. Can you see my Xcode? This is the correct project you wanted to look at, right? This is the one.
Yes. It's called Quick Table. It's one of my open source projects I did for myself, and then I was like, you know what? I can make this a CocoaPod because I had never published a CocoaPod before.
So what does Quick Table do? What was the problem that you were trying to solve here?
So the problem I was trying to solve is extremely bloated view controllers. I have a rule of thumb: less than 200 lines should always be the golden rule for view controllers.
Love that rule. What is MVC? Massive view controller. Ooh. Yeah, I like to keep all my files a big file just means code smell. A big file means this person just threw everything in there and didn't really give it much thought around structure. I think small files indicate that this person really, it takes time to make a file. You have to think about how it fits into the rest of the project.
You have to name it.
Right. And you're not just throwing code in there. I really like small files. I think that's a sign of an experienced developer. At least in my experience, as I've gained in knowledge and grown as a programmer. My first I think iOS app had like 3 files and they were all like 5 lines of code. And then you begin to realize that is a horrible way to go about organizing an application.
Right. And there's by no means a silver bullet for organization. There's MVVM, there's MVC, there's there's Viper, there's so many different paradigms, and each of them have their own pros and cons. I chose this one in particular because I recognized the pattern that I was doing. Apple was right when they said that the table view was one of the most used view controllers in the iOS world.
Oh, it's used everywhere.
Yeah, it's used everywhere. So, and one of the things that I'm almost always doing is displaying information on a table view, downloading something from the internet and displaying it in an array. So what this basically allowed me to do was quickly basically have a shell of a view controller that was like a table view, right? But it allowed me to inject into it like cells. Because I was injecting, I could then do unit tests on it. So my view controller could be 100% unit tested, and I wouldn't have to worry about, this line of code is not unit tested. Oh crap, what is it going to do? It also allowed me to explore like really how the table view worked. And then that's when I kind of discovered that, yes, you can use zibs with cells, but I can also do them by hand too and dynamically size them, and it's just more efficient. So mind you, this is a little bit older version of Swift. I haven't actually had time to update it, so you may see some funky stuff.
Yeah, I'm getting some Xcode error warnings, but no worries. So why don't you walk me through some of the structure here and how this works from a technical aspect?
Yeah, sure. So,
which file should I start out in?
Actually, that was the perfect file to start in.
Right.
So the crux of it is you create a view controller that conforms to the Quick Table protocol. The Quick Table protocol provides you with a couple of things. Specifically, your data adapter, which is the quick renderable. That's the meat of it. And then you have the option of adding a network adapter, and then some quick table delegate methods that I put in there for specific, needs for myself. And so when you initiate this view controller, what this protocol is allowing you to do is take over all the functionality of the table. This protocol is not meant to actually exist in a view controller itself. The view controller is meant to set up the UI and throw into what I call an adapter or an interface. So you have basically a class that implements this quick table protocol. And then from there, you say, well, my table delegate is now this class that is implementing this protocol. And the view controller has no idea what is going to be displayed in that cell. It doesn't even know how much data to display. Its sole job is to just set up the layout, the auto layout, and display the table. That's it.
So walk me through from there. Where do I go from there?
So from there, you have a couple of options. If you go to quick renderable, it's like the first one in the quick table folder on the left. Go over to, there you go. So quick renderable has two things. It allows you to set an object. So imagine a renderable is basically like a cell adapter. It holds the actual data that you're going to display on the cell and the cell itself. So its job is to dispense cells for a particular table view at a particular index path. But tables.
I'm sorry to interrupt. Why are you requiring that to be a class there?
I'm requiring it to be a class because it returns a UI table view cell, which is a subclass of UI, or it's a class inside of UI kit.
Right. And so that object in there is the actual data that is being represented.
Yes, it's in any object, and you can then do you can do an optional cast. So it can contain any object. There are many room for improvement there, especially if you just use a generic. But
right, that was going to be my next question. Was why in any object versus something more generic, something generic and type safe.
Yeah. I was I was kind of young in that terms of like using generics, so to
Uh-huh.
speak. I didn't fully abuse the power of generics in Swift. I will admit that. Um, but now I would. It's been about a year since I've worked on this, but now I would go back and really like abstract that too. So
Yeah, and create like an associated type that is a little more typeset. You don't have to cast it. Would be the primary thing. And
right,
the compiler will yell at you in various circumstances.
right,
Whereas with like an indie object, the compiler doesn't know what that means.
right, right.
Uh,
Um,
so take me from there. So we've looked at the renderable. What is this network adapter?
so the quick network adapter basically is you could actually separate out your network layer from your layer that handles the table view. So you could have a class that is specifically designed to handle all the data coming in and out of a table view, what cells to assign to that, and how a cell should be set up. But none of that relates to network. Like you shouldn't
Uh-huh.
have network tightly coupled with that. So
Right.
what the table network adapter allows you to do of anything that's shielded by the quick renderable, you can swap it out easily. So let's say that my table view, one day I wanted to display chat messages, but tomorrow I want to display images of cats. Fine, just change the adapter. You don't have to change the network out if you don't want to, or just change the network out, and you can have your table automatically handle that. So the table is unaware of what network is actually being called. It doesn't
So
even care if it is a network.
so the reusable here. Tell me what the point of that is, and how you actually went about using that.
Yeah. So the quick reusable is designed to be a protocol implemented on a UI table view cell.
Right. That's what it
Um,
looks like.
yep. So a table view cell has two things. You can either instantiate it as a class or instantiate it from a zip file or a nib. This supports both. I love using not having to type a string in. I love that you can do string describing self.self, which
Yeah, that's
means
the way I do everything. I think every project I start out with, like I create a protocol called custom string convertible,
Mhm.
which basically just has this like a custom identifier variable
Right.
with an extension that basically does this exact thing right here. Just returns a string describing self.self.
Right. Right. So the beauty of this is that because I'm doing an extension of that protocol, it is basically acting as the default for that, so that your implementing protocol class doesn't actually have to define what reuse identifier does. That's the beauty of and the power of extensions in Swift. You can have
Right,
a protocol with a default behavior,
right.
which is unusual in most languages.
Is it actually?
I mean, it's unusual in how they go about doing it,
Mhm.
because usually a protocol is supposed to be like a blueprint of what you're supposed to implement, but the
Right.
actual details of how that implementation is done is up to you. But to say then that you have a default implementation for a blueprint is kind of funky, but useful, very useful.
Oh, it's incredibly useful. So this file right here is where you're actually interfacing with the UIKit API.
Right. So here, this replaces your traditional having to register with the table your specific cells.
Uh,
So all I have to do is say any cell, any table view cell that implements the quick reusable, I can register it to be a part of this table.
right,
So on the table itself, I can just be like table view dot register reusable cell and give it that class, and it will inflate either from a nib if it finds it, or not. It could be the class as well. So
right. And I see you're using that the generics right there
mhm, mhm.
with the protocol constraint on it.
Right, exactly,
Uh, love
exactly.
seeing that. love the protocol constraints, and you know, I think the higher level you can write functions, the better. You know, writing functions like this that are super nitty gritty and that get down into the details it's generally a code smell. You don't want to be writing functions on that level. You want to be writing functions at the highest level possible, and encapsulating functionality in a way that is super generic and can be reused across a lot of in a lot of different use cases. And I think you're doing a nice job with that right here.
And the beauty of that DQ reusable cell is that the table view you can still DQ it and use the power of a table view and how Apple does table views. And the also beauty of it is that you never actually define any properties on a cell. So typically when you DQ a cell from the table, that's where you're setting like a text field, or this is an input field, or this is an image. Well, not with this library. You actually let the renderable item handle that. So it's responsible for when it's inflated and instantiated, it says, what object do I have? Okay, well now I know what properties I need to fill out for you. The table has no idea what you're doing at that point. So you're deferring all that to the actual responsible party, which is that class.
So yes. So is there anything else you want to show us in here, or did we pretty much cover everything on that? I think you did a nice job.
Yeah, that's pretty much covered. I mean, you can really see the advantage of using this when you look at the unit tests. They're very generic, but most of it is covered.
Uh-huh.
So awesome. You can have data adapters plugged into these cells, and you can say this cell needs to render this way. You can even instantiate an entire table view within this and test out its functionality.
So I think you did a really nice job on that. Let me hop back over into can you see me again?
Mm-hmm.
There he is. All right, so we're going to go ahead and